Hey, it's Workbench for Workbench Quagmire back with our free code camp 100 days of Python's 100 our free code camp Python certification in 100-ish days. How about that? Today we're in our graphs and trees section. Today we're going to tackle the first workshop in this. Implement the shortest path algorithm. Let's see if how much of this we can get done. I may have to split it into two pieces. In this workshop, you will implement the shortest path algorithm. You will write a Python function that computes the shortest path between nodes in a graph and also returns the path taken. For example, given a graph where cities are connected by roads with different distances, the algorithm will find the shortest route from one city to another. If you want to travel from city A to city D, the algorithm might find that going A, B, C, D, total of 15 kilometers, is shorter than going directly A to D, 20 kilometers. To get started, define the variable named inf and assign it the value float inf, which represents positive infinity. Later, you use it to indicate if infinity distance between two nodes. So. Step 2, you will need to create a 2D list to represent the adjacency matrix of the graph. The matrix will be used to represent the weights of the edges between nodes in the graph. Create a variable named adjacent matrix, or ADJ matrix. And assign it a 2D list representing the graph with the following weights. Okay. You'll now create the main function that accepts three parameters: the adjacency matrix, the starting node, and an optional target node. Create a function named shortest path that takes three parameters: matrix, start node, target node, and assign none as the default value for target node. The target node parameters is set to none by default, indicating that if no target node is specified, the function should compute the shortest path from the starting node to all other nodes in the graph. Add path statement inside the function. You need to store the number of nodes in the graph. For this, you will need a variable that matches the length of the adjacency matrix. Inside the shortest path function, create a variable n and set it to the length of the matrix. Step 5. You need to keep track of the shortest known distance from the start node to every other node in the graph. To do this, create a variable named distance and initialize it as a list containing a single element, infinite. Right now, the distances list only has one element. However, you need one distance value for each node in the graph. In Python, you can multiply a list by an integer to repeat it. For example, list of 0 times 3 creates that. 3 zeros. Update distance list to contain n copies of infinite times n. Step 7, now that you have your distances list initialized, you need to update the distance for the starting node. Since the distance from the starting node to itself is always 0, set the value at the start node index of the distances list to 0. So this is start node equals 0. Step 8. In addition to tracking distances, you also need to keep track of the actual path taken to reach each node. You'll create a list where each entry stores the path taken to reach the node. Initially, each node's path will just contain itself. List comprehensions provide a concise way to create a list. For example, x times 2 for x in range 3. Create a variable named paths and initialize it using a list comprehension that creates a list containing node no for each node no in range n. There we go. Step 9. As the algorithm runs, you need to keep track of which nodes you've already visited, so you don't process them more than once. To do this, create a list named visited and initialize it with false for every node. Step 10. In this step, you'll add a loop that will run once for each node in the graph. This loop will allow the algorithm to update distances and paths over multiple passes. Create a for loop that runs n times. Use underscore as a loop variable since you don't need to use the iteration value. Inside the loop, you'll need to prepare for selecting the next node to process by creating two variables. One to hold the smallest distance found so far in the current iteration, and another to store the index of the node that has the smallest distance. Create variables min-dist and current and set them to infinity and -1. Step 11. Now you'll need to check every node to find the one with the smallest known distance that has not been visited yet. To do this, add a for loop inside the main loop. The loop should iterate through each no node in range n, where n is the number of nodes in the graph. Add pass as the body for loop for now. So Step 12. You need to decide whether the current node is a better choice than the one you've already found, if any. To do this, you'll add a conditional statement inside the loop. The condition should do two things. Check if the node has not been visited yet, and compare the known distance to the current min distance. Inside the inner for loop, add an if statement that checks whether no node has been visited and whether distance no node is less than min distance. Add a pass placeholder inside the conditional block. Step 13, if the conditional you just added is true, that means the current node is the best unvisited option you've found so far, and you need to update your variables to reflect that inside the if block. Update min distance to distance no node. Distance is node no. And set current to node no. All right, we're about halfway through this. I am going to call this for today. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.